Alright, some nerds in this question are asking you to compute 25 base 10 minus 15 base 10 using 8 bits 2's complement representation. So what is this asking you to do? It's asking you basically first you need to convert this number and this number to 8-bit. Okay, that's our first step. And then we need to subtract them. Well, to subtract them, you need to convert that 15 base 10 to 2's complement. You only convert the negative number in the question into 2's complement, and then you add them. Because when you're converting it to 2's complement, you're making that number into a negative number, and then a negative, so you're making you're making this 15 into a negative, right? So it's gonna be negative 15 base 10. So a negative minus a negative is a positive. So then essentially what you're doing is you're converting this original question, you're making that into 25 base 10 plus 15 base 10. Which is much easier for us to compute than to just subtract them. Alright, so our first step here is to convert these two numbers, the 25 base 10 and the 15 base 10, into 8-bit. So there's two ways to do it. The first way, you would write, so each spot, you just multiply by 2 for each one. So like when you go to write 1, you'd write 1 right here, and that's how you write 1, right? To write 2, you'd write it like this. To write 4, you'd write it like this. To write 3, you would write it like that, right? If you don't know how to do that, then I don't know what you're doing. Okay, so now to get 25, we have using 8-bit. So we're gonna need 1, 2, 3, 4, 5, 6, 7, 8. I didn't write anything greater than 32 because, I mean, I didn't even have to write the 32 in there, but just to show you what comes after the 16, because you're not gonna get anything greater than 25 or 15, so I can actually just like even get rid of that. So I know these will be all zeros, because you're not going to go higher than that 32 that was here. So 16 plus 8 is 24, and then to get my 25 I want that 1, so those are both zeros. So this is to get 25. To get 15, you do the same thing again, so 1, 2, 3, 4, 5, 6, 7, 8. I know that I'm not going to go anything higher than the 16, and now I need 15. So 8 plus 4, that's 12. Plus 2 is 14, plus 1 is 15. So there, I'm done. Now the other way to do it, some people find this kind of trickier. You'd start by writing your 25 here, and you just divide by 2 each time. So 25 divided by 2 is 12. But then if I have 2 times 12, that gives me 24, right? I want to end with 25, so I need that plus 1. So I need a remainder 1 here. Now I divide by 2 one more time. 12 divided by 2 is 6. And then that's full, like, there's no remainder there. Right? Okay, now 6 divided by 2 is 3. Again, there's no remainder there. Three divided by 2, that's going to be, how many times does 2 go into 3? 1 time only, and I need my remainder of 1. How many times does 2 go into 1? No times. So it's going to be 0 here, and a remainder of 1. Right? Because 2 times 0, 0 plus 1, I want my answer to have a 1 at the end of it. And then here I have my, let me move this down actually. Let me do all of them for you. 2 times 1, that's going to be 2, plus 1, that gives me that 3. And then I have 2 times 3, that gives me 6 plus 0. Oops. That gives me that 6. And then 2 times, I already have 2 times 6, it's right there. So yeah, that's how you get these numbers. And then you would read this from bottom to top. So then this number becomes 1, 1, 0, 0, 1, but don't forget they're asking for 8 bits, so this is 1, 2, 3, 4, 5, 6, 7, 8. And as you see here, it's the same answers. You can do them both ways if you want, just to check your answer, or you can just do it the first way. Most people like doing it this first way. Just knowing this way though will help if the numbers are more complicated. because this is more like a guessing, like, oh, does this number add with this number? No, it doesn't. Okay, let's try this one. But then this division one, you're more prone to making mistakes, but it's better than just randomly guessing what numbers add to each other. Alright, so let's do the 15. So 15 divided by 2 each time. So 7 times 2 is 14, so you're going to have a remainder of 1. Divided by 2, 7 divided by 2 is 3. Then you're going to have a remainder of 1. 3 divided by 2 is 1, remainder of 1. This is 0, remainder of 1. So I know I'm going to have 1, 1, 1, 1, and then 4 zeros. And that's exactly what we got up here as well. Alright, so the first step is done. So now, so we have our 25. I'm going to write this in a different color. So our 25 here is 0, 0, 0, 1, 1, 0, 0, 1. And then our 15, 0, 0, 0, 0, 1, 1, 1, 1. They want it in 2's complement representation. So this 15 here, it's actually, we need to get it into a negative 15. To do that, you take 2's complement. So your first step is you want to change all the zeros into ones and the ones to zeros. So 15 is easy. You're just going to do 1, 1, 1, 1, 0, 0, 0, 0, and then you need to add 1 to it. Plus, literally, you just do plus 1. So now it just becomes 1, 1, 1, 1, 0, 0, 0, 1. This here is the 2's complement of that 15. Now we can just add them straight up. So here's our 25. So 0, 0, 0, 1, 1, 0, 0, 1. And then our 15, which is like our negative 15, but then a negative and a negative makes it positive. So then now we have 1, 1, 1, 0, 0. Oh, I forgot a 1. 1. What the heck is that? What is going on, dude? Awesome. 1, 1, 1, 1, 0, 0, 0, 1. Okay. So now, so 1 plus 1 in binary addition, I'm going to write it on the side here. 1 plus 1, actually it's probably better if I write it like this. You have 0 and a 1, 0 and a 1. 1 plus 1 is 0, carry a 1. This becomes 1. If I had this, it's just 0 and a 1. If I had, no, actually I want, yeah, that works. 0, 1, 1. If I had this, let's do this actually. Okay. If I had this, it's 0, carry a 1. Now I have 2 1s and another 1. So it's going to be a 1 here and a 1 and 0, carry a 1. Because these 2 1s here, 1 and 1 is 0, carry a 1. But I have this leftover 1 up here, so just change that into a 1. That's all it is. That's all there is to it. Okay. Actually, I should just keep that bottom part here. Okay. Alright. So now going back to this. I don't know what's going on with this glitch here. These just refuse to erase. That's fine. Just stay there and chill. Okay, so 1 plus 1 is 0, carry a 1, 1, 0, 1, 0, carry a 1, 0, carry a 1, 0, carry a 1, 0, 1. So now to know if there's overflow or not, you look at the last digits. So this here and this here, they're the same thing, so there's no overflow. If this up here was a 0, which it's not, then there would be overflow, but because they're matching, there's no overflow. And yeah, that's your answer right here. That's the answer to this question.